So to going forward, let's break down the first stage of information processing, and that's going to be the stimulus identification phase. So we will talk about that environmental stimuli that's coming through, and really it's presented yourself in multiple senses, right? So you have vision, you have taste, you have touch, you have auditory. So these are all the different types of senses that we're going to utilize to bring that environmental stimuli within ourselves. But oftentimes we're going to recognize patterns. So a lot of times with the visual and the auditory, we're looking for some patterns in that environmental stimuli, and that may aid in the ability for us to maintain or input that environmental stimuli. So this first portion of stimulus identification, sorry about that, is the idea of detection. And detection is really thrown through some neurological impulses in response to these stimuli. So as we hear something, as we see something, as we taste something, there's some sort of impulse within our brain that really triggers that detection. These stimulus are occurring in the way that we process these incoming stimuli, are done at different levels. And really, it's done in different levels until it contacts what portion of the memory it's identifying or triggering, right? So there's some aspect of these stimuli that are associated with some past occurrences or not associated with past occurrences, so it takes a little longer for us to identify these stimuli or process. And then really depending on whether or not there's a large memory associated with it or not. But when we come down to this, there are many variables that affect our ability to identify these stimuli in the environment. And you see those here in the different colors: clarity, intensity, and modality. Clarity is really the sharpness or how well something is defined. And we'll talk later on in the class about the idea of vision and how some things are related to sharpness and some are more peripheral. But this clarity of something and how easy it is for us to identify it really is speeds up the identification process. And then the intensity, right? So it's something very, very bright or something very loud or not as loud. So the brightness or the loudness of something is much easier to identify. Think about when you're listening to my PowerPoints and my lectures, or when you're listening to anybody present on the radio or in a lecture hall, the idea of a monotone, right? So that idea of being able to change your voice and the sound and loudness is going to affect how easily it is for somebody to pay attention to you or retain some of the information. And then the modality. And modality is really the way that you are receiving the information. And it affects the latency and responding. So, right, so the idea of two modes would be vision versus hearing, or auditory versus tactile and touch. And one of the things I want you to know is really the idea that the visual perception of a visual mode takes a longer for us to process than the auditory, and just that whole concept going forward.
So now I want to use this paper by Galen and all. So Schmidt is one of the authors of the textbook that I recommend for the class. But so this Galen 1983 paper, and I've also posted this paper underneath the literature component for the module 1. This talks about intersensory facilitation. And if you're going back to the previous slide, this is the idea that one sensory, like auditory, is going to enhance the reaction time of another sense, which is the visual, right? And so it's kind of been shown in some early work in the 1900s by Dr. Todd and his group that reaction time is improved by about 20 to 80 milliseconds in reaction components when you add in the auditory component, even when individuals are told not to kind of pay attention to that auditory. So this kind of paper here, and this paper goes through two different experiments, and basically what we're going to do is just kind of talk about the overall gist of it. And the idea is that there's this apparatus and they have to follow the stimuli and go through the motion. But what I want you to look at is, so these are all the individual subjects, and there's only 8, right? So all of those you that are looking at going into grad school, you'll know that nowadays 8 and 6 don't really fly for what we're trying to do, but because you need some more people. But this is the old world, and things were much more difficult back then because they didn't have computers like we do now. But keep in mind that these reaction times, and so remember RT for these that are all going to be reaction time. in these components. And then you have vision, auditory, and then VA, where they're put together. Down in this bottom one, there's a K, which is a kinesthetic, which is a torque component to it. We won't really cover that one. Really what I want to focus on is the top table, and the idea that, so if they did reaction time with vision only, you can see the values here, right? And so 214 milliseconds, 204 milliseconds, on and so on down. If they did it with auditory, you have a much faster reaction time, right? People tended to respond much better, except for 7. 7 seems like they're pretty close, only 8 millisecond difference. And then you have the combined, right? And there's supposed to be this intersensory facilitation. What you will notice is that if I compare the vision and auditory combined to auditory only, there is a reduction in reaction time, right? So by combining the two is less effective than only the auditory. But if I look at and compare this column here, the vision auditory versus just the vision only, there is a reduction, and it follows pretty soon, 20 milliseconds. There's some that don't have a less reaction change and others that do. And really it's the idea that the vision or the visual sensory causes a little bit of an extra period of time in the reaction component. Going forward to the pattern recognition, it's most often we are able to extract recognizable patterns and features from these stimulus that we feel very important or that we're familiar with, right? Somebody's face structure and a lot of pattern recognition and face structure, you can look at that. Walking patterns, and I talk to people all this time in this class and motor behavior and other classes I teach that. You're often going to understand or notice somebody from afar based off of features that you recognize before you can actually see them or hear them, right? So if I see you walking across campus and I know you, I have a better chance of understanding who you are from your gait pattern and just patterns in your movement, because that's right, I observe that quite a bit. And you can do it a lot too. You'll notice a friend of yours walking close before you can actually make out the very distinguishable features of their face, who they are. And then identifying pitch. We all have pitch. My partner is much better at recognizing pitch than I am. You know, she's a singer, and so she can hear pitches in people and understand that some people's voices are much easier for us to hear than others. And some of these things that are genetically determined, and then others are learned. And we'll talk about your perception on that, but there are things that go both ways, right? And then experience is thought to expose individuals to more patterns and features to recognize. And that is why we practice. And that's why we practice with intent, and that's why we learn. And that's how we learn, right? So through these experiences, we can increase our ability to identify and recognize patterns, which therefore is going to decrease our reaction time.